Hello everyone, I am Neha and welcome to our channel. Today's our topic is representation of number system. In last video, we discussed representation of number system. In this video, we will see next representation of number system. Next our number system is binary number system. Binary number system consists of 0 or 1, that means total 2 numbers. So base of the binary number system is 2. This is the representation of binary number. Binary number system, the greatest positional value is called as MSB. Lowest positional value is called as LSB. MSB means most significant bit. LSB means least significant bit. This point is indicating the binary point or the radix point. D0, D1, D2, D3 or D-1, D-2, D-3. It is the individual digit in binary number. Each and every digit have the individual weightage value. So D0 for the 2 raised to 0, that is the weight value for D0. 2 raised to 1 is the weight value for D1. 2 raised to 2 is the weight value for D2. 2 raised to 3 is the weight value for the D3. Same like that, weight value for D-1 is 2 raised to -1. Weight value for D-2 is 2 raised to -2, like that. What is actually positional weight value? It is the product of individual digit and the weight value. See, D3 into 2 raised to 3, that is the positional weight value. That means product of individual digit and the weight value. Let's see one example. 1001.11. The base is 2, that means it is the binary number. 1001.11, it is the individual digit in binary number. See, 1001.11, this is the binary point. The position of this 1 is the MSB and the position of this 1 is the LSB. That means it is the greatest positional value in the binary number and it is the lowest positional value in binary number. For this one, the weight value is 2 raised to 0. For this digit, 2 raised to 1. For this, 2 raised to 2. For this one, it is the 2 raised to 3. Same like that after the binary point, for this one, 2 raised to -1. For this one digit, 2 raised to -2. Then positional value, that means it is the product of individual digit and the weight value. See, 1 into 2 raised to 3, it is the positional value for this digit. 0 into 2 raised to 2, 0 into 2 raised to 1 and 1 into 2 raised to 0. After the binary point, 1 into 2 raised to -1 and 1 into 2 raised to -2. This is the positional value. And sum of all positional value is the binary number. Next our number system is octal number system. Octal number system represent in 3 bit of binary. The base of octal number system is 8. Octal number system again consists of integer part and the fractional part. This point is identified the octal point or the radix point. D0, D1, D2, D3, it is the integer part of the octal number system. D-1, D-2, D-3 is the fractional part of our octal number system. It also consists of MSD and the LSD bit. MSD, that means most significant digit. LSD, that means least significant digit. The greatest positional value for the D3 is MSD. Lowest positional value for D-3 is the LSD. As per previous discussion, same like that, each and every digit have the individual weight value. Weight value for D0 is the 8 raised to 0. Weight value for D1 is 8 raised to 1. Weight value for the D2 is 8 raised to 2. Weight value for D3 is 8 raised to 3. 8 is the power of our octal number system. That's why we have to use the 8. For the d minus 1, weight value is 8 raised to minus 1. D minus 2 is the weight value is 8 raised to minus 2. For the D3, 8 raised to minus 3. This is the total positional weight value for all octal number. Positional weight value is the product of individual digit and also weighted value. Let's see the one example. 462.12. The base is 8, that's why it is the octal number. 462 is the integer part of the number and 0.12 is the fractional part of the number. The value of 4 is the MSD bit and the value of this 2 is the LSD. This is the individual digit in our number. So for in integer part, the weight value for the 2 is 8 raised to 0. Weight value for this 6 is 8 raised to 1. And weight value for this 4 is 8 raised to 2. Same like the up in fractional part. 8 raised to minus 1 and 8 raised to minus 2. Product of individual digit and the weight value is our the positional value. And sum of all positional value is our the number. So see, 4 into 8 raised to 2 plus 6 into 8 raised to 1 plus 2 into 8 raised to 0. Dot, that means octal point, 1 into 8 raised to minus 1 plus 2 into 8 raised to minus 2. And this is our octal number. Next number system is hexadecimal number system. Hexadecimal number system is alphanumeric number system. That means it consists of numbers and also alphabets. The base of hexadecimal number system is 16. It also consists some integer part and the fractional part. D0 to D3 is the integer part of the hexadecimal number system. D minus 1 to D minus 3 is the fractional part of our hexadecimal number system. MSD, that means most significant digit, LSD, least significant digit. The weight value of each and every digit is 16 raised to 0, 16 raised to 1, 16 raised to 2, 16 raised to 3 for the integer part. The power of hexadecimal number is 16. That's why we have to select the power is 16 raised to 0, 16 raised to 1, 16 raised to 2, 16 raised to 3 like that. After the fractional part also same 16 raised to minus 1 for the D minus 1, 16 raised to minus 2 for the D minus 2 and 16 raised to minus 3 for the D minus 3. And this is the positional weight value. Positional weight value is the product of individual digit and the weighted value. Let's see one example. 432.13. The base is 16, that's why it is the hexadecimal number. 432, it is the integer part of our number. 0.13 is the fractional part of our number. This point is our hex point. Give the weight value for each and every digit. Weight value for 2 is 16 raised to 0. Weight value for this 3 is 16 raised to 1. Weight value for this 4 is 16 raised to 2. Same like that, a fractional part. Weight value for this 0.1 is 16 raised to minus 1. Weight value for this 3 is 16 raised to minus 2. And what is the positional value? Product of each and every digit into weighted value. See, 4 into 16 raised to 2, 3 into 16 raised to 1 plus 2 into 16 raised to 0 dot 1 into 16 raised to minus 1 plus 3 into 16 raised to minus 2. This is the representation of hexadecimal number system. Thank you.